I would describe myself as a part-time researcher and full-time cricketer. The broad theme of my research is to cut CO2 emissions from metal production sector. So traditionally, we produce metals by using carbon as a reducing agent. And what happens when we use carbon as a reducing agent is that we produce lots of CO2 emissions. For example, to produce 1 ton of steel, we emit around 2 tons of CO2. And same goes for the other metals. For example, to produce 1 ton of nickel, we produce around 20 to 26 tons of CO2, depending on the process we use to extract nickel. For example, we say, okay, we need nickel for the batteries, we need nickel for the wind turbines, but how do you produce nickel? The production of nickel itself produces huge CO2 emissions. So this means that we are simply shifting pollution from one sector to another without actually solving the problem. Instead of using carbon, now we use hydrogen as a reducing agent. So what happens there is when we use hydrogen, we don't produce CO2. What we produce is water as a byproduct from a chemical reaction of metal oxide reacting with this hydrogen. So to do that, we use electric arc furnaces. We have this conventional electric arc furnace where we fill it with a metal oxide we are planning to reduce, and then we also fill it with a gas mixture containing argon and some hydrogen. And then what we do is we ignite an arc between the tip of the electrode and the metal oxide we are planning to reduce. And upon the ignition of the arc, we break down hydrogen and argon into the plasma species. So we have an argon plasma species and hydrogen plasma species. And this process produces heat. And then we use this heat to melt the metal oxides. And this molten metal oxide then comes in contact with these hydrogen plasma species. They react, and then finally we produce metal from these metal oxides. So this process has some advantages also. For example, conventionally to produce iron, we use different units. For example, we sinter the ore material, we have to pelletize it, and then we do the blast furnace melting, and then we take it for the refining, dephosphorization, desulfurization. All is a very big process chain. But what we do here is we do everything in one single furnace. So we don't need pelletization, we don't need sintering. We can use the material as it is. We can use lumps, we can use fines, we can use ores. We can just throw them directly into the electric arc furnace. We reduce them, and what we have observed, we have also observed that this plasma helps in refining of the final metal product. So we remove silicon impurities, phosphorus impurities, calcium impurities from the final metal product that we are producing. So everything happens in one single process compared to the traditional blast furnace long processing routes. I also do lots of sports. For example, I play cricket and volleyball, but in particular here in Germany, I play a lot of cricket. Actually, I represent Düsseldorf in German Bundesliga Championship. And I think this is nice for me because I get to travel with people who don't only talk about science, reduction, hydrogen, plasma and all, but they talk about some normal stuff and gives me the opportunity to travel and socialize with other people. The thing that I like about the research is the independence and the freedom to work on my own ideas, to explore something which I find very interesting, follow it to the end, and in the process contribute something valuable to the society.